Yo, what up, tech friends? Check out this clip from one of my favorite episodes this year. Happy holidays, you filthy animals. I'm Stephen LaMarca, AMT's technology analyst.
And I am Benjamin Moses, the man who didn't comb his hair this morning. That's one nice thing about getting old is like no one will know.
I blame it on the motorcycle helmet.
Oh, yeah?
Yeah, I get to do that one. I have that luxury.
Oh, yeah. That's a good excuse.
The big cost is like, you could die on your way to work.
In this area, that is a high risk. Steve, we got a letter from our editor at large.
Yeah, so my babe Tom Feldhausen over at Oak Ridge National Lab, he sent me a text wanting to set the record straight and clarifying the workshop that I spoke so highly of, by the way, on our last episode. So the workshop, the hybrid manufacturing workshop at Oak Ridge National Lab, I'm just going to read what he said. It was a workshop on human factors for hybrid additive manufacturing. How do we train the next generation of operators, designers, and users of the technology for adoption? As well as how do we develop digital tools to augment the operator? My favorite line. We haven't automated machining in its long-standing history. How the heck do we think we can do it for hybrid AM? Thus, we need to train.
Nice. I like that correction.
So,
thanks, Tom.
Yeah, if you listen to last episode and you're like, man, this guy's really like off his rocker, you're not wrong, but this is the correction to what that workshop was. Again, I hope they invite me back.
Also,
probably not now.
If it took you the last episode to realize you're off your rocker, that's a long time for you to learn. You should have picked that early in the sequence.
It's like your car, when the check engine light comes on, just plug into the OBD2 and reset the codes. That's what I do. I just reset.
Yeah,
nothing's wrong.
That's good. And actually, hopefully we can meet up with Tom at our next Technology Use Committee in Corpus Christi. We have a joint meeting with the DoD down there. And that'll be one of the interesting topics we're going to talk about is additive. One thing we want to talk about is what is the current state of additive, both on end use and technology. But also, the DoD is going to run into issues on technology adoption. So knowing what are the technology hurdles, getting into... Obviously, additive, it will be a big part of the defense strategy, but knowing that, what the limiting factor could be just humans. And how do we support that or prevent that path going forward? So,
did he agree to it?
I'm going to talk to him today.
Okay.
Tom, you're going to agree to it.
Man, I hope so. I hope I didn't ruin that relationship. But by the way, he also sent us a perfect thumbnail for this episode, which is the hypersonic rocket nozzle with a water bottle in it.
Thanks.
So you might not know when you see this, but when you listen to it, you'll know. Also,
I heard you got a bone to pick with CAD.
Yeah. So speaking of being off my rocker, there was that, and even so. Jason Jones, I was sitting next to him at the happy hour after the first day of the event, and we got talking, and it's always a blast talking to Jason Jones, but of hybrid manufacturing technologies. He said we were talking about something, and CAD came up, Cam came up, and I went on the same tangent I almost always do when somebody brings up CAM, and that I think the current state of CAM software and technology today is absolute garbage, and these CAM companies should be ashamed of themselves because they're constantly advertising on how easy they make CAM today and how even a monkey can do it, and it's saying stuff like that, and it's well, I guess there's a lot of humans that are monkeys that can't do CAM. And because there's a whole engineering role in the manufacturing workflow specifically for doing CAM.
Right.
These people never get to leave their desk, and they are told, "Hey, we just sold this part." Or we just sold a contract for us to make this part for this, aerospace or defense company, and we owe them like 100 million of these parts, and they have to be made using 5-axis. Design something,
Right.
or make this design work, and that's what a CAM engineer has to do. And like they're paid a lot of money to do this.
Sure.
Their job hasn't been replaced by software yet, and it's 2023. And so, like, I don't know, but anyway, Tom and Blaine introduced me to Brad Rooks.
Sure.
I mentioned him last time. He works for Hypermill, and they were like, it's funny. They started the second day off by telling Brad this, and Brad, as soon as he came in through the door, he was like, Steve, I need to talk to you about CAM. And I'm like, let me get a drink first. But anyway, yeah, he's like, great guy.
Sure.
Hypermill is an incredible company, and they've got an awesome product. And he was trying to talk me off my ledge, and we came to an agreement about CAM and the current state of it.
Yep.
And while like toolpath optimization,
Sure.
modern day toolpath optimization software is incredible, especially Hypermill's. Shout out to Hypermill. But still, going from design to G code is impossible.
It's a long process.
So we haven't solved that yet. And he told me some things that made me feel better about it, but it's still awful. So
I'm glad you got that
happened.
And I think that is an important lesson learned in terms of to your earlier example of signing a contract to shipping parts. The entire process of, okay, now let's define the manufacturing process, and then therefore I need raw material, I need tooling, I need work holding, I need all these supplemental things. But it's circular reference because I need some of that in my tooling process to design what the CAM looks like to get the G code, but I have to design that along the way. So it's a very interesting, take a step back if you're not in that world every day, if you're in that larger world.
Yeah.
It's tough sometimes.
And to be fair, a CAM engineer's or manufacturing engineer's only job isn't just to turn a design into G code. It's to take the design that the sales team and the customer came up with that is nearly entirely unmanufacturable and inconceivable.
Right.
And they have to make it a feasible program that the machinist can run. And the machinist is going to come back to the manufacturing engineer and be like, what did you give me?
Yes.
This can't be done. It's like, we've got to make it work. They've already wrote the check.
Yep.
It's a nightmare. I feel so bad for these people.
The manufacturing engineer is usually stuck between a hard place, right? The operator on the floor is like, what did you give me? And then he's stuck from what we signed the agreement to. But the most successful companies that I've found, especially when you look at high precision parts or like parts for aerospace or defense or space, they try and get involved early in the design process. So they'll see a contract, they may bid for it, but I think a lot of times they'll add the exceptions or provide feedback to say, if you can do this, this will get you a better yield. So providing that design for manufacturing feedback or DFM as part of the RFP process, that's where I see successful companies taking the next leap into new segments and new sectors. But that's tough, man. Being a contract manufacturer in 2023 is tough.
And I again, a shout out to Brad at Hypermill because I gave him a tongue lashing. Like it was 7 a.m, maybe 8. I don't remember.
Wait till you get involved with welded assemblies. That's a whole new world. Steve,
Are you done?
Ramia, can you tell us about today's sponsor?
Today's sponsor is the Modern Machine Shop Made in the USA podcast. Tune in for Modern Machine Shops Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn. I read that thing 3 times, and I still can't read.
It's all good. Steve?
Yes, sir.
Testbed. I heard we got a robot.
We bought a robot.
Oh, I know we got a robot.
I
Robot,
bought a
y'all.
robot. So
Tell me about this robot. Did we name it?
we haven't named it yet. We're gonna wait for Doug to
Yell at
insult
us.
it in some way, and then we'll turn that insult into its name.
Perfect.
So we bought an Aegis Rebel 6 Degrees of Freedom. That is the actual name. It's Aegis Rebel, and like some of the letters are capitalized in Rebel and some aren't. I think whatever.
Yeah.
And the full name is 6DOF for
Nice.
Degrees of Freedom. So it's a 6-joint collaborative robot that has 660 millimeters of reach with a 1 millimeter accuracy claim, which is great because there's only one other company, as we know, in the automation industry, in the manufacturing industry, that has an accuracy claim, and that's Fanuc. So there's like,
That's fun.
we're going toe to toe with Fanuc on a budget robot, and so I'm like, let's do it. But 1 millimeter of accuracy, 660 millimeters of reach. And then, being that it's a collaborative robot, it's limited to 15 newtons.
Yeah.
So
Nice.
get what you can out of that for speed.
Yep, and I think an important part of this in the conversation of our robot is the constraints. It's got to be able to fit on our table. It's a tabletop factory.
Right.
And reach everything we need on the table, which the 660 millimeters will get us. But also, it has to be less than $10,000. And that's constraints is very
tough
important for
ask.
us. And obviously, it's got to have the safety requirements of a collaborative robot because it's an office environment. We're
Yeah.
not putting shielding. We're not putting fencing in an office space.
And I think here's the other cool thing, really cool purchase point that I appreciated out of it. It's made in Germany.
That's cool.
It's a German-made robot that's under $10K, and I compared it earlier this year. Another German, affordable, not affordable enough, unfortunately, but another affordable German industrial robot, the Horst, by Fruitcore Robotics, another German company. They were like on the same website that I used to buy it, which is actually an Aegis website. They have this website called rbtx.com for sourcing, and it's a supplier of what they call affordable automation solutions and affordable robotics solutions. It was a brilliant purchase experience. Paid for it on a Thursday. It arrived the following Monday.
Wow.
So was not expecting that in the slightest. I had equipped on the website and in the shopping cart the end effectors or end of arm tooling that I wanted and whatnot, and some of the other accessories and software packages, and some of them weren't in stock yet, and they told me about that, and they told me we're only billing you for the robot right now, but like a couple days later they sent me an invoice for, okay, we have everything in stock. Second we get a payment, we'll ship everything to you, or maybe whatever, however it goes. And it was really impressive, and I think that they were able to get a collaborative robot made in Germany for such an affordable price for us, because it kind of hit me like Aegis is like the Magpul of the manufacturing industry.
Sure.
They really specialize in plastics.
Okay.
And where you think most robots need to be like made out of metal, and like the important parts on this Aegis cobot are made out of metal. It's like the drivetrain in each joint is like metal, and also it's swappable. So like when you break it, you order another one and you bolt it in there. And the rest of the robot's body is made out of what I assume is carbon reinforced plastic.
Okay.
Carbon reinforced like glass filled nylon, something like that. And it's a very quality plastic that like, I don't know if you've handled it yet, but it feels like Magpul plastic.
It's very
which
robust.
is quality plastic.
It is. It's very good. Nice. And
I haven't done anything with it. It's still in its box. I opened the box so people can see that we have a robot. And the day it arrived, I walked it around the office and like shaking it above my head like a Tuscan Raider. I was going. That's going to be a soundbite. And. I'm just very proud of it.
It is.
We got another cool thing about it, the controller box.
Yeah.
So like with a lot of robots, you have a massive controller box that you have to place out of sight.
Yep.
in our last robot, the U Factory X-Arm 7, great bot, had a professional like control box with the e-stop button on it that we put underneath the bench. This one's control box is located. They've integrated everything into the base of the bot, and it's got a nice wide base for support and leverage. And it's got a remote e-stop button.
Oh, nice.
It's wired. It is hardwired, so it's not wireless. Which you wouldn't want an e-stop button to be wireless.
You're losing it here.
Yeah, that's the one thing you want to have guaranteed, like a solid connection at all times with like 8-gauge wires. We can place that wherever we want. It's a really cool kit.
Yeah, and I'm excited to see when some of the accessories comes in and get up and running. That'll be a fun experiment.
Yeah.
Good. I'm glad everything's working out well, and hopefully our Mexico Tech Center doesn't steal this one for a little bit. If they do, that's fine.
They can buy their own, man.
Thanks, Steve. I'm excited to get that up and running. Steve, you want to tell us about Legos?
Okay, Legos. Reuters posted a story about Legos recently. Let me get the actual title.
And I do like this article because it fits in our material science section.
Yeah.
As we look at the whole life cycle of new materials, but also where those materials are sourced.
Right.
That's an interesting place where we're seeing a shift in the industry.
Right.
So I think this hits on a lot
and
of
I should
elements.
have an article coming out soon in the MT magazine about sustainability being a bad word. And one of the examples that I use is talking about the type of plastic that is a byproduct of cracking crude oil into, fuel.
Right.
We naturally you get Vaseline out of it, and we've got more Vaseline than we can sell. We pretty much giving the stuff away, and obviously plastic to make like disposable water bottles and whatnot. But I use them as an example, and Lego's research kind of like tapped into how can we get away from that. And Reuters has the article: Lego abandons effort to make oil-free bricks. Financial Times reports. That's the title. To be clear, Lego has multiple projects going on the right plastic blend to make these Lego bricks. Isn't for like a material science purpose that we think of in the manufacturing industry. Isn't for like strength, tensile strength, and toughness and whatnot. They're doing it because they need the right amount of luster. In the colors and the plastics and they want the even coloring, and it's like that's fair. You've been doing it this way for I feel like almost 100 years now, and like they're going to need to do put a lot of money into researching a new plastic to replace something that's become a staple.
And I thought you were headed down the point where they needed to be strong enough so when you step on it, it almost kills you.
Yes, but there's a correction to the article to state that this was only one project that they decided to cancel. And
to be fair,
they still have many other projects trying to replace the plastic to get a more environmentally friendly plastic in Lego kits.
And I appreciate the correction in the article because Lego does a lot of innovation in their entire life cycle of a product, from the design to the environment that they create for their designers to their products and even like packaging and instructions. Have you built a Lego thing recently?
Right behind you, boy.
Exactly. So back to your idea of Cam, like giving you instructions on how to build this thing, it's very impressive.
Yeah.
So to go from that design to, instructions on how to build it and then manufacturing those products, Lego's doing all right.
Also, like don't sleep on everybody's like, oh, Lego, it's a children's toy. It's like, dude, there are CAD programs. There's CAD software out there specifically for building stuff out of Legos.
Yep.
And it probably doesn't have awful cam associated with it either.
Let's get to some NASA sample parachutes. Elissa, you contributed something today.
Yeah. So this is from the same source, but NASA asteroid sample parachutes safely onto Utah desert. So this is about the OSIRIS-REx. It was a collaboration project between NASA and the University of Arizona and a bunch of other entities. We have gotten the biggest sample that has ever been taken from an asteroid. It ended up being 250 gram sample.
Wow.
And that's 8.8 ounces, which doesn't seem like a lot, but compared to this is almost like in some ways an extension of a project that Japan did about 10, 15 years ago. Well, most recently they had one come in 2020, and that only had 5 grams. So we had a substantially larger sample than they did. Excuse me. Yeah, so the asteroid is Bennu, and it's one that constantly circulates the Earth. It's one of the few asteroids that could potentially like hit the Earth. But they're like, nah, it's like a it's a near zero possibility.
When do we call it a moon if he keeps rotating around us?
I mean,
Doesn't it have to be big enough?
I don't know.
Well, the asteroid it's as wide as the Empire State Building is tall.
There you go. That's a big boy.
But it is still like substantially smaller than the asteroid that killed, or like the asteroid that killed the dinosaurs.
Nuke it.
And I do like.
It's one of many that actually circular that like orbits the Earth.
I don't like it. I don't like it rallying around the family with a pocket full of shells like that. Nuke it.
So I do like this article on a couple layers. One, I think you mentioned early on, is the collaboration between NASA and Arizona, and that's where I found a lot of innovative. We were talking about this earlier, how some of the other collaboration, like students and other companies, they're able to put stuff in space.
Yeah.
Like Arizona students and some of the other contributors towards this, they're contributing earlier in their career. And that's where I found a lot of innovation of being able to propose a problem statement to either students or a group that's not familiar with that environment and get some really wacky ideas. You're going to get some wacky ideas, and maybe one of them might actually make, but that wackiness gets you, innovation and further ideas that'll get you pretty far.
Yeah, I mean, a lot of the pieces that came from that were actually on the OSIRIS, they were either developed by U of A, ASU, and then like you said, the regolith X-ray imaging spectrometer, which is also called Rexus. That was a student experiment between Harvard and MIT.
That's cool.
So students actually, and another fun fact, Brian May of Queen was also on the OSIRIS-REx team.
Wow.
Yeah. So, he just creates top hits for like 50 years in his spare time and is an astrophysicist as his day job. So
How did this thing collect the soil sample? So we had to launch this.
Yes.
It had to successfully and safely
Yes.
land on the asteroid, scoop up its little dirt.
Yep.
And then
Jump off.
launch and fly back.
Yeah.
And safely land here.
Yep.
So
And this is entirely automated. We didn't send a monkey up there.
no, yeah. So it actually had a lot of the pieces were actually like the first of its kind, and including one which is the TAG-SAM, which is the touch and go sample. Like it's the arm, it's the robotic arm that Lockheed Martin developed in order to collect the actual sample.
They develop it or they white label it?
Well, no, they developed
Okay.
it. It's at their center in Denver.
Okay.
Which is like they have like a ton of like innovative like 3D printing and stuff going on there too. So it's called the TAG-SAM, which is the touch and go sample arm mechanism. And that is what it's also like we're the first to like land on the actual asteroid and collect the sample and then relaunch
That's right.
into orbit.
Catch up, India.
Could you imagine if we put the U.S. flag and we see that thing passing every once in a while? Oh, look at
Amazing.
this.
Yeah, and then I know we talked about the parachute too, and the parachute that they were worried it didn't deploy because they were getting consistent like messages as they were expecting, and so it's called the drogue parachute. They didn't get a message that it deployed, and then it was like once it had entered a certain point in the Earth's atmosphere, they got the message that it deployed, and Dante Laurietta, who is the head of the project, he said he burst into tears.
I bet.
When he heard.
Yeah.
So, because this project, it originally launched in 2016.
This is a generational project,
Yes.
isn't it?
So it launched in 2016. It reached Bennu, the asteroid, in 2018, and then it spent 2 years orbiting. And then in 2020, it collected the sample. It left in 2021, and then it had to travel 1.2 billion miles back to Earth.
That's a great project.
Yeah.
Talk about reliability.
Yeah.
The dedication.
It's wild. So, yeah, I mean,
Catch up, Toyota.
no, I mean, I love space, and I think it's completely fascinating that like we were able to do something like this. Considering where we were even like 50 years ago, we were like I say just going to the moon, but like we were going to the moon, in 1969, and now we're, able to send a fully automated robot basically to an asteroid and have it send back samples. So yeah,
NASA's great because we're prepping for this earlier when we were talking about like their design process, how they incorporate various simulations and prepare for this. So they launched it 6-7 years ago. There's a lot of prep before that. NASA does not say, let's do this tomorrow. So the fact that, the journey itself was 7 years, but realistically it's probably like a 10 to 15 year journey from inception.
Well, and the source you sent me for the Jet Propulsion Lab, they said that parachutes are the hardest thing to test.
Yeah, definitely.
Because it's a textile.
Yep.
And it's the hardest thing to predict. So the parachute is always kind of left up to chance, no matter what, I think. So they design it as best they can, and then they're like, all right, fingers crossed.
That makes sense. I mean, having seen somebody go skydiving before, I did not actually go up in the plane and jump, but I was there for emotional support.
You witnessed it.
And I think most of the time while we were there was like signing all the documents.
Oh yeah,
it's like buying a house.
Yeah,
there's a ream of paper that you have to go through.
Yeah,
come on, guys, get to some DocuSign.
I mean, it was wild.
Some DocuSign.
So the last article I want to talk about is 3D printing for submarines. It's interesting timing when you get to this article because we contacted by an organization that's looking at the industrial base for just for submarines. So on the podcast, we've been talking about the different divisions and their area of focus on how to improve their supply chain and how they can incorporate automation or at point of use manufacturing. And this article talks about the need for catching up on the supply chain to catch up producing number of subs. So over the past couple of years, we've been delayed a little bit, both on the shipbuilding, but also supply chain to support the ships being built. So the article from Naval Technology talks about U.S. naval industry integrates 3D printing methods for submarines. And I like it because it's two layers. One, they're using marine-based alloys, so stuff that's very corrosion resistant, copper-nickel alloys, and copper-nickel castings. And that's the last part is very important because they're trying to replace difficult castings with additive or 3D printed parts. And I think that's an interesting approach, short term at least. Where we can start seeing value is, the change of those designs, so to harness the full value of additive. But I think they've got a couple years catch up, and part of what the defense is trying to do in this particular area is being more prescriptive about their scheduling. The article talks about their inability to actually schedule when a ship will be complete. So being able to catch up the supply chain to accurately predict their production schedule will allow them to better improve their components in the future. So I thought it's a pretty interesting article, both on the materials and where the defense is headed for getting these parts. And of course, they're looking at, obviously, you're going to 3D print these big parts now, you got to machine them. So I think it's using a very similar infrastructure that they would for castings, just changing the source of the raw material from, a pour to, 3D printed part.
Yeah.
So hopefully this turns out well, and hopefully you see some, cooler technology come out of this.
It's interesting seeing that like basically all branches of the military now are embracing the 3D printing.
Yeah,
in some way,
absolutely.
They
shape, or
really
form.
are.
So not just the Air Force, which is always kind of on the cutting edge, but like all of them are really starting to embrace it. So, I mean, if it works, it works, right?
My favorite is still the T-handle to adjust the front side post.
It
works.
it worked, and they had a great point for doing it. At the Oak Ridge workshop, there was a military boy there who explained how important that actually was to me, and I'm like, I apologize.
You did a lot of apologizing at Oak Ridge.
Listen, man, often wrong, never in doubt. But that's science for you. You'll never know unless you get things wrong.
Thanks.
I guess.
That's beautiful.
Ramia, where can they find more info about us?
amtonline.org/resources. Like, share, subscribe.
Bing bong.
Bye, everyone.